All right, the video got cut off without me realizing it, so here's the finished part of that row on the table. Then we got to decide for step 5 that we need to identify the minimum or the maximum. So we knew from the beginning that we were trying to find the maximum, so the biggest point, the point that's going to create the biggest P, the biggest profit. That ends up being 5, 0. So when x equals 5 and y equals 0, that maximizes profit. Okay, maybe you need to pause this now and write it all down. Otherwise, we'll go ahead and start the second example. So with this here, we've got the same idea going on. We're going to follow the same steps. So step 1, graph the constraints. Finding the intercepts here, whether I cover up x or I cover up y, both intercepts here are going to be 6. Get my straight edge out, try to get a lot of grid points here. Got that. Now, these right here might look strange, these double inequalities, but remember we talked about this as being trapped between. So being trapped between the two. So in the x direction, in the left to right direction, I got to be stuck between 0 and 8. So I'm going to put up some boundaries. Remember, that's vertical. So I've got vertical lines for x. Saying left to right, I've got to be stuck between 0 and 8. Then in the y direction, the up-down, I'm stuck between 0 and 5. So here's 0 for y and 5 also for the top. And what you'll notice is now I've got 2 different regions here to pick from for my feasible region, that trapped region. So if I look at this, the cutoff is what side of this line am I on? So that was the diagonal line. So with this here, I'm going to know that I need to be greater than. Greater than is above, that is to the right. So my feasible region is this region here, the trapped region to the right of that line. And then I'm going to identify those vertices that make it all the way around. So I have this one here is 1, 5. Here is 6, 0. Right next to it was 8, 0. And up in this corner is 8, 5. I will plug those into my cost function here now. 1 for x, 3 for y becomes 1 plus 15, or 16. Plug in 6 for x, 3 for y, 6 plus 0, or 6. Plug 8, 0 in, 8 for x, 0 for y, 8 plus 0, or 8. Then 8, 5 being plugged in, 8 plus 15, or 23. So the goal here was to minimize. How did I know minimize? It says right here, to minimize means I want the lowest. So the lowest point, lowest cost was 6, 0. So an x of 6 and a y of 0 got me there. I'm all set. Problem done. Number 3 and number 4, I want you to try those on your own. Number 3 is a try your own problem we did in the notes. If you got questions on that, let me know. Number 4 was the homework assignment.